Yeah, perfect. Thank you guys for staying up this and coming here. It's important for us to you to show here, and it's important for you as well. So let's start with the presentation today. First, 30 seconds brief introduction about me. I'm Alok Adhao, and I'm working as lead system engineer in EPAM, and I'm a Microsoft MVP. Along with that, I have a YouTube channel where I try to provide the demonstrations on Azure, cloud, and AI technologies. The project that I have created today, that we'll be discussing now ahead, I'll be creating the entire playlist on how to do it from scratch. I'll be giving you the link at the end of the session, so if you want, you can connect it, and then eventually this series will start so that you can follow along. But for that, let's connect today's session and let's see the background of it. Okay. We have already gone through with Leru and the first session about model context protocol, A2A protocol. Yes, we have gone through. It's very new. These standards are still evolving. But can we create a product right now, as of now, with these standards? I say yes, we can create it. And the product that we are creating right now is, it is an interactive, user-based interactive application which can interact to Kubernetes cluster. How many of you know Kubernetes, AKS, containerization, simple things? Okay. I don't want you to be very specific for this project that, okay, Kubernetes, okay, if Kubernetes you don't work, this is not for you. No, it won't work that way. Kubernetes is just one of the tools that we are interacting. The concepts relates the same, and it will be similar for any other tool that you wish to work on, and we'll see how. Okay, so we'll go quickly through Agentic AI concept. We have gone through multiple times. I'll just touch base. Model context protocol, how we have implemented in the project. We'll see the actual source code and the demo. Then comes the agent-to-agent protocol. There was already showcased a good demo, a quick demo on that. We'll just evolve more things on top of it. Okay. Then vector store. We all know about the databases, right? We have SQL, NoSQL databases. With AI, we use another kind of database which we call as vector store database. We'll see that as well. And then there is something called as RAG architecture. Leru did touch base on that. We'll see the practical implementation in this particular project. And then we'll see the complete end-to-end project demo, and we'll go through it. Okay. What is Agentic framework flow? Agentic framework has these components broadly. Okay. Input. What can be an input? Usually, in the previous demos, or you know, it's a user prompt. The prompt or the text that we enter in some kind of field, eventually it goes to some kind of agent. The agent, the request goes to, is called as master agent. It is one of the agent in the agentic concept. Okay. Why do we need an agent? We already know the microservices concept. We already know the monolithic concept. Why are we calling this agentic? Because it is specially manufactured to connect to any of the LLMs. What is LLM? Large language model. How many LLMs we have? We have plenty of it. Okay, we have OpenAI, which is the famous one. We have Azure OpenAI, and we have Cloud AI, and there are many other OpenAI models that we call LLM. Why agentic? Because it has more brain than a regular microservice or a traditional microservice. How? Because it has the capacity to understand using LLM. It can plan the work to achieve a particular goal and also take action against it. Okay? And to do this part, it has in its arsenal other agents. These are the agents just like this one. Okay? Let's consider you are the owner of one company. You want to expose one of the agent. That means you are exposing an agent card. We'll see what that card is and how that is defined for sure. But then when you talk to another person, you give your card, right? Your card has some details, your name, email address, how to connect, right? Then during agent to agent also has those kind of similar connection details. Okay? So those things connects the other agent to my master agent. That means if there is something that my agent cannot do, and it knows there is another agent somewhere in the world running which can do that particular work, it will reach that. Okay, that is one of the options, and this is very big. This can go as complex as it can. How many agents? It's enormous. Then we have the vector DB. Vector DB, we just talked this in the AI concept. There are vector DBs, that is vector DB. And then we have the memory. Memory is the user context. What do you mean by user context? Just now I said I'm prompting to the agent saying that, okay, I want a doctor. Okay, the doctor, I'm having headache. That is my first context. Now the next context I'm talking about is, okay, I want the doctor I just want in 5-kilometer radius. Are these two prompts relevant? No, because first prompt was only saying I want a doctor, and second prompt says that, okay, I want it in 5-kilometer radius. How would my agent know that these two things are common, and it has to smartly understand that he needs to find a doctor within the 5-kilometer radius? Simple concept. How would it know? Because it is managing some kind of context. Context is just, it is storing into database, keep on storing, and then it is using it when required. Okay, and then we have the tools. What are the tools? Kubernetes is one of the tools. How to interact with Kubernetes? kubectl command. Everyone will hate here. No one loves to memorize the commands, right? Get pods, get this, big commands. So we'll translate that concept to human interpretation. We can communicate to Kubernetes using the user communication. Okay. So model context protocol. We have gone through this now multiple times. Okay. So what it is an open standard to connect any of the LLMs and the other AI related agents. Okay, and then because it is standardized, everyone is using it. Okay, it is open source and it is universally adapted. Why do we use USB-C now? It is universally adapted. That's how this MCP protocol in AI world, whosoever will create an agent on the AI world will use the MCP concept. I won't take much of the time, but then it is specially used to integrate with any kind of LLMs. So because there are many LLMs, many tools, many agents, there should be a standard that will take everything together. That's MCP. And the next one, which is A2A. Okay. This is the product. Okay. We have a React-based UI in the right side that you can see. I'm talking from prompt to pod. Okay. Something I'll text in the field. I'm saying, give me all the namespaces. In Kubernetes world, who don't know, okay, what I'm saying is one of the component in Kubernetes cluster, I want to pull it, but I don't know the command. I want to pull it though. How would I say it? I'll just say in the regular language, and then the prompt will go to my master server. Previously we have seen this master agent. Okay, so this master agent, here the request is going, which is my Azure OpenAI. I said it has brains. How it has brains? Because it do some kind of evaluation. Wherever you see this cloud kind of thing, yellow cloud, it is a LLM. Okay, it is trying to understand itself. Okay, so if you see 3 clouds, yes, all 3 where we are using the LLM, and we'll see the actual source code of this as well. Okay, let's go to the point. Request came. Evaluating the tool from the registered tools. So there are 3 tools that we have used. That is AKS list tool, which is this one, AKS doc tool, and the AKS create tool. 3 tools we have, but then every tool has its own purpose. Just by saying get me all the namespaces, how do it know which tool to call? That's first kind of intelligence. Second, if you want to call one of the tool of this, there might be different arguments of those tools that it requires. That is the basic input, right? If you want to do something, you need certain specific arguments. So how did it know what kind of arguments to call? And third, eventually it also acts on it. That is reaching towards the goal. It will actually call that tool with the arguments. Okay? Because I'm saying list me all the tools, it is checking, okay, AKS list tool, doc tool, create tool. Which one? It will select the list tool. It will go to the OpenAI. So eventually it selected one of the tool. Once the tool is selected, then it gets to the function of the tool. Simple function, everyone knows in the traditional concept. It is just a simple function which got an argument. Simple. Then from there it connects to the LLM again, whichever LLM we have. Here in particular we are using Azure OpenAI, and then we are asking it to generate a command. No command is pre-stored inside the entire product. Okay, it is generating the command with respect to the text. The text says give me all the namespaces. It will generate a command qctl get namespaces. The entire text will be handled and request to the AKS, to the actual tool. You can think of this tool can be even a simple VM as well, and you can ask LLM to create a Ubuntu command as well. As simple as that. Okay, so this is the Kubernetes, and whatever is the response, it is taking and showcasing it to the user. Simple. That way we have the second tool, which is the doc tool. Okay, I don't want to just block this one to this product to connect to the Kubernetes cluster. Every bank or every company have some documents, right? And always for any document you need to manually go and scan and check what is the real content inside the document if you want to find one. What if I say you, I create this prompt, and in the prompt only you can ask few of the stuff which you know that should be in the document, and the document will list you few of the contents here in the same prompt, right? Powerful. For that I have created this particular doc tool. It is using the RAG architecture, we will see on this, but eventually it is for this. And then we can not only list the resources in Kubernetes, we can also create the resources in the Kubernetes, in which we'll ask the LLM to generate the YAML files. No one knows the syntax, no one knows the commands, but still will be able to manage it just by simple user prompts. Okay? Let's see. Next part is agent to agent architecture. First is A2A, we have already gone through, so I'll just shortcut on this part. A2A protocol, because I want to speak with multiple agents, and because there are multiple agents in this world, every company will create its own agent, will be creating the agent card. Okay, and then why it is used only to coordinate between the agents, and it is cross-platform. It doesn't matter where you are creating your agent, to which platform, which area, doesn't matter. Until and unless it is exposing its card, that is a contact card, it is sufficient, another agent will understand what that is. Okay? This is how the agent-to-agent protocol is implemented in the source code. Let's go quickly. This is the agentic chatbot. Do you see agent.json? Okay, this is one of the agent. This agent has exposed its contact card. The contact card has few of the standards, and this is standard by the A2A protocol. It says that give me the name of the agent and give me the URL where it is running. Right now, because it's on my local, I'm just keeping my own URL. This, and the third important thing is this part, which is argument. What kind of argument it takes, and then is it a planner agent or not? Planner is a new thing. Okay, let's see. If I have my own agent, my agent has its own brain, saying that okay, which tool I need to use. It has multiple tools. Let's suppose there is another agent someone else is running, and it also has multiple tools. Okay, his own, and he don't want to expose that. Let's say it's a doctor tool. Okay, find a doctor tool, and mine is a technical tool. If I want to connect the doctor tool, my technical tool, would I be adding all the tools that are present in the doctor tool? No. Why would I do it? I will do it simple, that if the context, that is user prompt, is saying that it is related to doctor or whether, it will go to that agent which has its own brain to select one of the tools that he has in its answer. Okay? So this is how the contact card works. Okay? So a request came from the prompt, that is, some question is asked. MCP planner, that is my master tool, my tool master tool. Here it will evaluate from the registered MCP planner and tool. That means this is the planner which has better brains, which has internally multiple tools. So it will evaluate, my master agent will evaluate whether to request to the planner, and when it requests to the planner, it will just forward the user prompt because it doesn't know what is the arguments to pass to the tools that we have internally in this particular agent. And in the right side, if you see, we have a weather agent. This is just for a sample, it doesn't have anything to do with the Kubernetes tool, but to give you a context of doctor agent, here we have the weather agent. What I'm doing is same standard of contact cards. Okay, we have the name, we have the contact details, we have the argument this time. Here the argument was only a simple prompt and it was accepting the prompt. But here this is a tool, less brain. That means it is very specific. It requires a very specific parameters. The parameters are city and field. That's all. Okay. So if you have a planner, it is more optimized. If you have a tool, that is also good, right? It is doing its work. And my master agent will take the decision where to go with respect to the user prompt. If user is saying about Kubernetes, go here. If user is talking about weather, go here. Brains, have I done this? No. It is the LLM who is deciding. I'm just giving a good prompt to this LLM. Okay? That's it next. Let's maybe go behind and I'll just show you some of the sample, how it is working on. This is the Agentic AI. The left side one, the AKS tool. This is the agent which is actively running right now. And here in the agents, if you see the MCP server, we are all continuously talking about the MCP server, MCP servers. So this is kind of a server class. It is just defining that I'm from the MCP.js protocol. This was important. And once this is instantiated in server.js, where it is instantiated? Here, MCP router, MCP server. Okay, this server is instantiated. I've just created an instance, and then the magic happens here. We have add tools. How do we know which tool to add? We have got the tool details from above. I have 3 tools here, or 4 rather. I'm only showcasing you 3, but we have 4 tools here, and all 4 tools are added. These tools are nothing but a simple class. Don't take it too much complicated. A tool has only few responsibilities to showcase. First is, it should just have some kind of accepted arguments or parameters, and then it should showcase a handler function, which is this one. Traditional, a function which is accepting some kind of argument. Nothing more in that. Any language will support this part. Okay. So if something is accepted, it will be pointing to this tool, and this is the brain of the master agent. Okay, MCP. This is how it context. AI is not magic. Okay, agentic AI not magic. We are telling the context. Okay, when we are talking to LLM, we are giving 2 contexts to him. First is the system context. System context, which is not shown to the user. And the second is user context. Of course, what is sent by the user. So this is the system context, which is very much important, the brain behind the selection of the tools. What it says that these are the tools available in my arsenal. Okay, first thing, in the server.js, we have already added 3 tools, simply speaking. And then here we are defining whatever is the tool name. These are the available tools. First tool is this, that is generator. I'm giving some details about it when this tool should be used. Whenever I want, this tool is used when the user describes the Kubernetes object generation, you need to create a YAML file, okay? And this is ideal for when user wants to create some custom resources in Kubernetes. This is how we tell what is the input format should be. We are talking about this input format. In this tool, the request will come as a prompt. And also we are talking about wrap inside this particular, this is the argument detail. So once you select, once you finalize that this tool has to be used, this is how we pass the argument to the tool. Okay? This is very much important, and this will keep on going. As much as I give the understanding to the LLM, it will behave properly. Otherwise, it will hallucinate and it will select wrong tools or no tools. Okay? So it's my responsibility to have right prompts to it. Okay? Likewise, I have the generic list tool that I have here, and then the other tools are also listed. That is documentation tool. We'll go through it. But then this is the brain of Agentic AI. Okay? How it is called? If I go to Agentic Planner, here if you see, how do I talk to that? This is ask. Context I've shown. This is the function which is taking these two things, that is the system prompt and the user prompt. System prompt, we just saw how it has to select a particular tool. Against what? Against the user prompt. That is full prompt. If you see the full prompt, full form prompt is two parts. One is the contextual history. What user said in last maybe 10 conversations. Right now I'm just maintaining 10 conversations. But if I'm going in production for multi-user, I'll be using our traditional databases, and I'll just push the user context, whatever the user is saying, what is the response coming back, everything I'll keep on pushing to that database against that user ID. That's how the OpenAI works. You keep on asking it, it will take your context and it will respond you back what is you're saying. When you're talking about Java application, it will never respond you with the .NET codes. Okay? Same with the business part. So how it is done? It is done with this contextual memory. Very simple. What we are doing? We are connecting to the Azure LLM. Azure LLM is present here. We are using Azure Foundry. From Azure Foundry, so if you know everything and anything related to AI tools in Azure, you'll get in Azure Foundry. Okay, and we have the multiple tools here. The model to select. Right now I'm selecting some kind of model, and then let's me go to the model catalog. You can always save this particular Azure AI Foundry. From you have the model. First you select the model, and here only you will have the vector data store as well, which is the beneath part. Okay, we'll go through that. So from here I have created the OpenAI, Azure OpenAI instance, and I'm connecting. And from here I'm just pointing to that OpenAI with two things, the system prompt and the user prompt. And with respect to the context, it will select the tool it has to. Okay, once one tool is selected, it will just go to the tool handlers. Every tool has the same format. It has always the handler function that is going there. Okay? You get the concept? Perfect? Let's go there. Azure Vector Store. Why this is used? I've just said to you, you have company documentation, you have to go against each and every document there, and then you want something that will understand all the document. It will try to chunk, that means short strings about all the data that you have, embed, because the vector data store only understands the embedded concept. So chunking, embedding, storing, simple concept. So this is how it works. Then why it is faster? It is efficient to retrieve the data because it is embedding and chunking in that part, and it is high dimensional data. What is high dimensional data? Simple saying, in the traditional databases when we push some data, we give name equals to something, ID something, category something, standard, right? But in the vector data store, when you push it, it is not the standard, it is some unique numbers against some kind of chunk of data. That unique number will be 0.1, 0.445, 0.323, that you cannot understand, but the LLM and the communication will understand, and that's why it is much faster to communicate with this kind of vector data stores. So this one gives us. And then we have the RAG architecture. We're just talking about RAG only. That is retrieval augment generation. Retrieve the data from somewhere, augment it, that means ready to read and then actually read it. Okay? Why it is used? Improved accuracy, interact with LLM. LLM give you can understand what is the data and it will bring it. This is the architecture of this RAG inside the product. Okay? Two things. One is pre-created. I've just shown you the Azure Foundry, right? In that Azure Foundry, this part is I have already created, and the above side is what is happening when the user adds some kind of prompt. Okay? User says, get me some kind of Kubernetes resource, depends on what kind of file it is there. Let me go behind. Okay, so what is happening here? Pre-configured. What are pre-configured? First is Azure Blob Storage. Standard blob storage, any kind of files can be pushed there. From the Azure Blob Storage, I have created a simple server, not agentic, nothing, a traditional server, which will chunk, embed and store it to the Azure Vector Store. How it happens? If I go to the UI, Azure Foundry, Vector Store, this is my Vector Store. Okay, this is the store that you see, and these are the files that I have pushed. You see the three files here? Concept, setup and reference file. These are just Kubernetes random files, doesn't matter what those are, but eventually my prompt will understand and try to find the right data. So if I say from here, if I say something related to those files, it will actually go to my master planner, from master planner to the agent to, it will create the argument. Now we know this part, right? How AI works or the master agent works. It will call the MCP tool handler of one of my tool, and from there it will create a thread. What is thread? In Azure Foundry, if you want to use something that we need to create the assistant. Assistant is just a communication part. This is a assistant, and every assistant will have a thread. If you want to communicate through UI, you can directly do it from here, start typing and it will showcase the same result. But then if you want to programmatically use it, you need to create one assistant, and from there you need to create a thread, and on that thread we can utilize it. Okay, going back to the architecture. Okay, so what I did, I have created a thread, added the user question, the question that I've asked, I'll add to the user question and run the thread. This is how, whatever is the response, it will try its best to get the data for you. If it doesn't, then it will respond that I was unable to find that particular data inside the documentation. Okay, this is still evolving, and the better you chunk the files and push it to the vector store, the better you will get the results. Right now, I've directly pushed the files to the vector store. Let's see how better it will go. Okay. Okay, AKS chatbot. So what all things are part of this product? We are doing the natural language interface. We are doing the Kubernetes integration. Then we have the real-time command execution. You don't need to learn the commands. The command will be auto-created and it will be executed. User-friendly design, nothing much, it's just a prompt. Okay, contextual awareness. Now we know what is contextual awareness. That is also added. MCP, yes. A2A, yes. And then the RAG for document search. Simple. Let's try for a demo. This is my assistant. Prompt to pod. This is created in React. Here, let's see what is my cluster status. right now. What is my cluster health? Do you know any commands how to get the health or anything from the Kubernetes? No. Do you know all this, how to get it? It will try to connect to one of the servers that we have. If we go here, from here the request came here, it generated the text and it has passed. I have a full response about my cluster, which says what is my cluster components, which are this, how many nodes I have, do I have any failed pods? No. Do I have any failed deployments? No. Cluster analysis complete. But right now, there is nothing, so let's try to create something. Are you okay? Too boring, huh? For sure? You okay? You want me to continue? Continue. Okay, thank you, sir. Thank you, sir. Okay, so we know there is there something in this cluster? Get me all the pods. Do I know the command? No, I don't know. I'm just saying user prompt, get me all the pods inside the cluster. It will try its best to create the command and get me the output. Okay, this output is rendered in this using React, but this is the showcasing is not AI, it is just a UI that I've created. Okay, so I have two pods here which are in default namespace, which are running, which is good. And if I want to edit this pod or any of the details from here, I can just start typing and say name Alok and apply. Once we apply it, it says okay, this is configured. Okay, let's say get me all the pods in default namespace. Last time our prompt was different, get me all the pods. Now I'm just giving a different prompt. It's not every time exact. Okay, I'm asking LLM to understand and create a command for me. Let's see which one I have created. Is it this one? This looks a bigger one. Okay, this one. Here it is. Let me see. Let me apply it here. What is the pod name? Test167. Name colon Alok. Apply. Okay. This particular H2 is configured. Get me all the pods. Okay, the H2 one, if I go to the let me find it, Alok, you see the labels are added, which is Alok, name equals to Alok. What else I can do from here? If I want, I can delete it from here, but because it's a deployment, what is deployment? I don't know how many deployments are there. Get me all the deployments. I did a spelling mistake if you see. Can a command execute a spelling mistake? But here, let's see. The LLM tried its best to understand what the user is trying to say, generating the right command and showing me a particular deployment. So this is the deployment that I have. Great. So it is trying to correlate what is user trying to say. Now, okay, I have it. Get me all the namespace. Again, spelling mistake. It's good, right? You do some fault, but LLM will take care and give the right results to you. Okay, so these are the namespaces. Good. What else I can do? These are all listing. It's good, right? But can I create something? It's best, right? Maybe create a deployment with name. Say your name.
Kim.
Kim. Kim. Okay. With image nginx. I'm not giving the version to it, okay? Every image requires a version. By default, it should take latest version, right? I'm not giving it. Let's see. And then I'm saying that give me replicas. That means how many pods I want. I'm saying give me 3 replicas. Also, create a service for this deployment service which will expose all the pods of this deployment, and on port 4400 something random that I'm saying. This is my requirement. Let's see what LLM is trying to do against this. Creation of a deployment. It is trying to first understand the context. You are talking about creation. It went to a totally different tool, that is creation tool, and it brought me this one. It is me who has coded, so I prefer to first showcase to the user what it is trying to create and give an opportunity to the user to edit something if they want. If not, you can directly hit apply to cluster and it will apply it. What it has created? A deployment with Kim, replicas 3, we asked for it, okay, and nginx container, and then it has also created the service. The service is pointing to 4400 that we wanted. Cool? And this source code or commands or YAML files are not there in the source code. It is dynamically generated by the LLM and getting it back. Okay? Let's apply. Okay, it says deployment is created, services is also created. How do I believe? Get me all the, I'm doing very hateful things. Too bad. Let's see how it can understand. It still understands what I want to say. It is the context. Okay, it brought me the Kim deployment. I can go, I can edit this part if I want. If I don't want, we'll see. Let me see the pods. Get me all the pods. Because it is default, if I haven't given any of the namespace name, by default it will go to default and get all the pods required. So these are the 3 pods which are running right now with the Kim name. Okay? Thank you. Okay, so I want to see something failing. Okay, I want to fail this. Get me the deployment. I'm very bad at writing, if you see, but that's okay. Okay, and if I go to Kim, and somewhere I should have the image. Here I do a mistake, and this will not be rectified by the LLM. Okay, and I apply. This is edit. What we have seen? We have seen list, create, edit. Now it is edited. This should recreate all the pods. We'll see. Get me all the pods. Okay, you see some new pods are being created. There is only one pod which is trying to create, and it is in the pending state. 2 are still there. That's the Kubernetes functionality. It does not forcefully recreate all the pods if one is not working. What we can do? We can go and forcefully delete the previous ones. Okay, get me all the pods, and now I should see all the 3 in the pending state. One pending, okay, it has already created. Which one I'm deleting? It should work as of now as well. I don't want to get inside. The next thing that I want to show. Every day, SRE is assigned to check the health of the prod environments. He always needs to go in the morning, check things. Okay, there are monitoring tools and everything. I agree to that. But always there is a person who is checking the data. So, get me cluster status. Now something is failing, right? So it should grab that part and showcase to us that this is not working well. One part is failing, and it has also given us the detail why it is failing, which is just one command, a user prompt. You don't even know what the Kubernetes command are, what it did in the background, but you can still work on it. Good, right? This was all MCP. Let's see the agent to agent command. I've talked about you that there is a weather command. Let's see how is the weather in London. It is actually going to LLM. First, you see it is switching the context. My agentic AI is switching the context, which particular tool to use, what arguments to generate. This time it understood, okay, now the user is talking about a totally different thing, not Kubernetes. How is the weather? So it is telling me the weather is clear, warm, and a bit breezy, which is good. I'm not happy with this response. I want some specifics. What is the temperature in London? And now I'm asking a specific question. It should give me specific answers. What is the temperature? 24 degrees Celsius. Nothing is stored. Everything is coming dynamic, and it is being utilized. Okay? Same for Singapore as well. Get me the in Singapore. It will try its best. I'm not doing anything. I'm just calling one of the APIs, which is times, I guess, times or temperature. It just gives me the data in JSON format. I'm just feeding that inside the LLM. Okay? So it is giving me the real-time humidity about the data. Okay? So this is, simply speaking, these are the concept agent to agent and MCP that we have, right? So this was the demo. Questions? If it is not too boring, I should expect at least one question. I'm happy to answer. Anything. No question is a bad question. You can ask. Yeah. Maybe. Yeah.
Actually, all these are wonderful. How about the cost?
About?
The cost.
Cost.
Yes.
Okay. One thing I'm paying here is the Kubernetes cluster because I'm using the AKS. That has its independent cost. Okay. Second thing, I'm paying for the LLM because I've created a LLM instance. It will only charge you as much as you have used. Okay. By default, there is a limit of 8,000 tokens per minute, and that is free. Ahead of that, you need to pay. Or in a minute, if you are giving more tokens to LLM and bringing back the data per minute, right? So you can wait for a minute if you want to keep your free status. Okay? Out of that, it will always give you docs. I'm just trying to try something. It's not planned, but in this agentic framework, whenever it does some kind of work, so this is the RAG framework, okay, RAG framework. I just said, do you have any document? So it literally got me the Kubernetes documents out of the data I fed to him, okay, and it has also given me the files from where it got the references about that user count. Okay, the same thing if I do from my own React application, it will also give the same results. But then I am interested into this token. Do you see the token number? Okay, if this is passing more than 8,000 per minute, then you will be charged. If not, you are saved. Okay, so this is how it will be passed. The rest I am not paying for anything more. Vector DB may be costing you some pennies, not much, or $1 or $2, because it depends on how much data you are ingesting into it. Right now, because I just fed few of the files into it, it should be okay. But as the data grows inside the database, definitely it will be chargeable. So yeah, that's the answer. Ma'am.
Actually, a follow-up on this question. So access to this Azure OpenAI system is free.
Azure OpenAI.
This,
No. The LLM? No.
This interface that you're using.
Hi, yes,
Platform
interface is free. Yeah, you just need to go to portal.azure.com, and from there you can navigate to the Azure Foundry.
So like anyone can create an account.
Anyone can.
The LLM is not free, so I have to like input an API from GPT or Claude or.
You can use anyone that you want. You can use any Azure OpenAI, GPT. Yes, anyone. If you already have a subscription in GPT, you can use that one as well. Okay?
And the tokens that you're talking about,
Huh.
are these like is Microsoft Azure going to charge me, or are these the tokens that the LLM is going to charge me?
Because the LLM is Azure OpenAI, so Microsoft will charge you.
No, but it's GPT-4.
Yes, so it is inside the Azure environment.
Sir,
Okay, you can select multiple agents here. If I say model catalog, you can select as many agents you want. Microsoft has done an amazing job to give you the option, select your agent as you want. I was using GPT-4. You have so many other options here. Use whichever you want, and it is in the ecosystem of Azure or Microsoft. The billing will be controlled by
Yeah, I
Microsoft.
think we have Microsoft, you know.
Oh, yes, we have the best person here.
So sad.
Yeah.
But then, like,
I
my
mean-
confusion is, sorry,
Yeah.
but my confusion is that I'm already giving it an API for an LLM that I'm already paying for.
Ah, okay. So in that case, you are referring to the fact that you already have API access through OpenAI directly, right? Okay, that's a valid option. So in the end, Microsoft provides you with all of the OpenAI models through the Azure portal, right? So this is called Azure OpenAI Service. Nonetheless, you can also consume those models through OpenAI directly. So if you've got access to platform.openai.com in that case, you're already paying for API access to OpenAI. You can obviously also connect.
how Microsoft charges if they consume the model through Azure OpenAI or Azure AI Foundry?
That's a good question. I think through credit card, right? You know that better than I do.
Yeah, pay as you go.
Yeah. Exactly.
Yeah, I think I got this question similar from my customer. Like, why are you charging me for the hosting and I can only just pay for the model? Right?
Yeah, exactly. So this is also something that Julie has just mentioned, right? We've got different deployment options. So first of all, you can just be charged for the tokens that you're going to use. This is called pay as you go. It's similar to what you know from the OpenAI platform, right? I think this is also pay go. But then we've also got an option where you like have some dedicated reserved instances. This is called PTU, Provision Throughput Units, and in that case you would reserve something in advance and you would pay for it on a monthly commitment or a daily commitment or an hourly commitment, which is a little bit cheaper, right? But you've got dedicated and SLA backed throughput. So these are the two deployment options that we have. Anything else,
Is that
Julie?
clear? Clear so far? She's still like,
So
Maybe we
the
talk
answer
offline.
to the answer to your question is you can consume the models through various API endpoints, right? So if you already have consumed them through OpenAI directly, that's perfectly fine. And all being shown here in that demo is compatible to the other endpoints, right? Another option to consume the OpenAI models is through the Azure OpenAI service, so through Microsoft Azure, right? That's just a different option. You could even think about using third-party models from Anthropic or whatsoever, you know, being deployed through third-party services. Even that would work. Obviously, Microsoft has an intrinsic motivation that you would use the Azure OpenAI service.
Okay, in the event of we are exceeding our time, you can reach out to Seth. Okay, he's here. He's not going anywhere, and he can.
He'll sleep here.
Maybe after we go, he will be leaving, but he's here.
Hey,
You
let's
can
have a
reach out to
photo.
him, and he can solve all your doubts. In the meantime, yeah, I just need another 5 minutes.